Okay guys, so let's talk about salt solutions. So when we have a salt, it has three kind of possibilities. It could create a neutral solution, it could create an acidic solution, or it could create a basic solution. And we're going to go through each one so that you understand what's going on. So a neutral solution contains equal amounts of hydronium and hydroxide ions. And when we neutralize an acid base with a base, we create salt and water. And that salt may have an effect on the pH of the resulting solution. So, and here are the answers to all those that I just gave you verbally. And the nature of the A and the B that you see there in the salt are going to control what the pH is of the resulting solution, because that salt is also soluble and can then react with water. So, it is not a neutral solution necessarily, even if we have the same amount of acid reacting with the same amount of base. And that's because the nature of the salt is very important and what it does in solution. And so that salt will determine whether the solution will be basic, acidic, or neutral. So we have four possibilities since we have strong and weak acids and bases. And we're going to go through each one of these. So this video might be a little long and I apologize in advance. So when we have a strong acid with a strong base, we will result in a neutral solution because both conjugates are too weak for any change in pH to be detected. The strong acid completely dissociates in water and will not reverse its reaction to reform that acid. And the strong base completely dissociates and it will also not reform into the base. The next two are the ones you're going to have to worry about, and I will never give you the last one. So, when we have a strong acid and a weak base, the weak base is now going to control our pH after the reaction is over. And that weak base will create a weakly acidic solution. The strong acid's conjugate base does not contribute to the change in pH at all, because when I form that weak base, it can react with, and the weak base forms a conjugate acid, and that acid can then donate some hydrogen ions into solution. When we have a weak acid with a strong base, now that weak acid will form a conjugate base as a product. That conjugate base can then react with water to then create some hydroxide ions in solution, which would then cause the pH to be above 7, and it would be a weakly basic solution. And like I said, this one I won't ever give you the solution when you have an acid or a base, because a weak acid with a weak base is because you would have to know the Ka's and Kb's of each to determine it. So it's beyond the scope of this course. I know you're excited. So I'm going to go through some examples. When I have hydrochloric acid with sodium hydroxide, the first thing I want to do is look at my reactants. And both of those are strong. It means it completely dissociates. So then when I look at the salt formed, I can determine the effect that the cation or the anion will have on solution. And when I form chloride ions from HCl, I get a very stable, unreactive anion. When sodium hydroxide reacts and dissociates, creating hydroxides in solution, sodium is a very, very stable cation, and it is also very unreactive. And so this will not have any effect on our pH because we have two unreactive products. Problem lies when we have a reactive product, and we're going to go through those two situations next. So, again, look at your reactants And that's where we start always. And we have to identify whether HNO3 is strong or weak, and if NH3 is strong or weak. So nitric acid is a strong acid, and NH3 is a weak base, as you can see with the title of this slide. So, looking at those products, the NO3 is very stable and unreactive. However, the ammonium, which would be the product of this reaction, is not extremely stable and it will react. So this anion has no effect on the pH, but the cation will produce hydroxide or hydrogen ions by dissociating in the reaction you see at the bottom. And so what would this have on the pH? Well, if I'm creating hydrogen ions, I'm going to have a pH less than 7, which means it would be acidic. And so when I have a strong acid with a weak base, the salt will create a slightly acidic solution. What if we have a weak acid with a strong base? So let's say we had something like acetic acid, and I didn't write out these because there was lots of subs and superscripts and stuff, and sodium hydroxide. Acetic acid is a weak acid, and sodium hydroxide is a strong base. Sodium will be unreactive. Acetate is reactive. And I'm going to ask you to write out what that effect would be on the pH of the solution. What would acetate be able to do? So, as I said, weak acids and weak bases are not tested. I will post the answer to that question that I asked you here on this slide in another video. So, buffers I'm going to talk about tomorrow, and I will start out with the answer to the last question that we had today. Thanks for watching. Don't forget to comment with your name and period on this video. Thanks.